Can someone give me a more descriptive definition of what rational means? Vincent?
Can be expressed as a fraction.
Okay, great. Can be expressed as a fraction, and the way that we know that that's what it's talking about is because ratio. When you say, we were just looking at dividing an interval in a ratio. It's like this to this, dividing it into fractional components, right? So rational functions. Now, we've met rational functions before, right? This is your classic rational function, and it gives us a hyperbola, right? Something with a hole in it, and it does other cool things like it has asymptotic behavior and all that. So this is pretty standard though. This is about as standard as you get. You could shift this thing. You could shift it left or right or up or down. You could stretch it, reflect it, all that. But these kinds of things are going to be a little more complicated, okay? So I've got for you kind of a 5-step process. Now, I hate thinking about steps as just, okay, if you just mindlessly go through this, then you'll be able to work out what this shape looks like. However, at the same time, being fluent at a skill, at an algorithm, lends you power and allows you to analyze something. Take a seat. So, to help you remember what my 5 steps are, okay, I'm going to write some words on the board, and as I write them, I just want you to pronounce them, okay? This is a simple task, okay? Can you pronounce that? There, good, okay. Can you pronounce this? Very good, okay. Can you pronounce this? Now, this is why I'm so glad I'm a native English speaker, because this makes no sense. It makes no sense whatsoever. It's there and where, and it should be. It should be. We even know that it should be that because
it's sphere.
when we write this, we say spherical, right? Like only strange people say spherical. Okay, so this is my crazy English moment. Now, if we wanted that to be pronounced the right way, then you'd kind of spell it like this. Like that's sphere, right? Like that's unambiguously sphere. And that's my mnemonic for how to graph rational functions. Now, these words, they go in a certain order. I did my best. I've actually modified it over the years. I used to have a version that you couldn't say because it didn't have enough vowels in it. It was just like, and you're like, what is that? Okay. Good morning. I could make a proper word out of this by putting the S at the end, but as you will discover very shortly, the order of these letters actually is quite important, okay? So write this down, sphere. It's so very close to being a real word. And these are 5 steps for how to graph a rational function, okay? So I'm going to do something a bit difficult, which is show you all the steps first because they're a bit tricky on their own rather than give you one example, and we'll look at the different ways in which these are useful. Okay, so SFAIR, what does it stand for? It stands for symmetry. You want to take your rational function and see if there is any kind of symmetry to it. Secondly, you will need to factorize. The reason why you factorize is so that you can note some particular very useful geometric features that you're going to need to put onto your graph, namely asymptotes and intercepts. Okay. This last step is not always required, but for the harder ones, it is an enormously useful tool, but it's kind of the trickiest part of the whole thing. And R stands for regions. So it's not always necessary. Often by the time you've gone through the 4th step, you're like, okay, I've got enough information here, I can work out unambiguously where this goes. But this number 1 is very useful, and number 2 is quite powerful once you realize the insights that it gives you about the function. Okay, so these are our basic headings. Now let me tell you about the particular things that we are looking for in each one because some are more useful than others. Symmetry. On Friday, you learnt about the kinds of symmetry that a graph can have. What are the 2 kinds? Odd or even. We've alluded to these before, right? Good morning. So we're looking for odd or even. Okay, that's the particular thing you're looking for in symmetry. Now, just let me make a quick note here. Why is this up front? Most functions, the vast majority of functions out there, are neither odd nor even. They're not symmetrical, okay? However, we give you very specific functions which are often trying to test if you understand whether this is a thing or not. And also, if you do nail whether it's an odd or an even function, and you get that right at the front end, it's quite easy to determine whether a function is odd or even or not. And if you get it, right, everything that you are about to do is halved. All the work you're about to do is halved. Because if, for instance, you work out it's an even function, okay, once you get, for example, an asymptote somewhere, like say x equals 2, if it's an even function, that means it's symmetrical this way. So right away you have another asymptote, namely x equals -2, right? And then when you work out intercepts, and then when you work out these, so if you spot some symmetry straight away, right, you've halved your work. So that's why it's worth doing up the front. Factorize it as one fraction. Often what you'll be given is, for example, if I gave you this, right, I could add something to this. Morning. Okay. So I could add that, right? Now this is a rational function, but it's not written as a rational function at the moment. It's written as the sum between a rational function and a constant. Okay. To turn this into a properly rational function, I need to put it all as one fraction, which would be 1 plus x on x. Okay. And then you would factorize if need be. This is already factorized because it's so simple. Okay. So if what's given to you is in a whole bunch of pieces, put it into one, and then factorize. Okay. Next step, asymptotes. Okay, this is going to be a big idea. Okay, there are 3 kinds, or I should say 4, but 3 really important kinds of asymptotes that you can find. What are the kinds of asymptotes that we know about? Okay, the first easiest type of asymptote to find is a vertical asymptote. Okay, and then after that, you can either get a horizontal or what we call an oblique asymptote. We'll talk about those particular kinds of asymptotes. The funny thing is, they're actually, like, the only thing these guys have to do with each other in common is the fact that they have asymptotic behavior. But the way you get a vertical asymptote and the way you get a horizontal or oblique asymptote is completely different. All right? Also, there's a 4th kind of asymptote that I'll tell you about later because you don't need to worry about it really, but they're still interesting and I'll show you. Okay. Intercepts, that's pretty simple. There are 2 kinds and you're looking for x and y, so that's just like any other normal function. And then the last step, regions, we're looking for where the graph is either positive above the x-axis or negative below the x-axis. So we're looking for positive or negative regions. Okay.